Okay, so, and before we can go on with this, we need a little bit of code on Game Manager. What we are going to do is we're going to create a header called board, okay, board variables. And under this, we're going to create a public list of vector freeze. And we are going to create a, and the reason I'm doing it like this is, let's say for instance, you are halfway to solving this, which means the puzzle is not in the starting state or the goal state. You need to figure out what cells are where on the board for the computer to figure out what is where. And there we will use the positions. It is really important that these positions must be in order. And what I mean with that, if we go to Excel again, is the top left must be first, then this one, then this one. Essentially, the indexes of our list will look something like this. And that is how our goal state will be in our game. Remember, these are the indexes, not the actual cell value. So if we go into Unity, go to Game Manager, I'm just going to drag Game Manager to the top and UI Manager right below that so we can find it easier. So in positions, I'm going to set that to not 9T, but 9. And then I'm just going to correspond the different positions of my cells to the index here. So cell 0, or cell piece, will be 0, 0, 0. And in Game Manager, it's going to be 0, 0, 0. Cell piece 1 will be 1, 0, 0. And in Game Manager, that should be 1, 0, 0. And there we should have all the positions in the correct order. And now if we go to cells, all we can do is select all our cell pieces while holding control. A little tip here. When selecting Game Manager, you can click on this little lock icon here to lock this inspector on Game Manager. So even if you click on other objects, you will still see the Game Manager's inspector. And this is useful for dragging objects that you need to select multiple of. So and there we have all the cell pieces. Now, the reason this does not need to be in order is because we have the positions in order, so we can use that to calculate for order. And just hit Control S, and we will be back to our Game Manager. So, just a little test, I'm going to create a public list of integer called board. And we're going to use this to calculate the board. What I'm going to do is I'm going to create a list of type integer. I'm just going to call it TMP for temp equals new list of integer. Now, this is important because if you just did what I did up here, as in if you don't add equals new list of type integer, it will technically not be instantiated. So you will get does not exist errors or stuff like that. But because these variables are public and in the Unity editor, we add values to that manually, the game engine instantiates the variable for us, so we don't need to take care of that. So in calculate board, we will do the following. We will create a for loop. Just as another trick here, each time you type in something and you see this little symbol next to it, all you need to do is press tab twice and it will autofill the code for you. In this case, we want int an integer of I, and I want it to go to smaller than 9. And Each time we do this, we will go for every var item in cells. And because we have this over here, and because it's already populated with cells, we can access that data. Okay, so what I did just there is I said for every item in cells. So what it's going to do is it's going to access every single one of these. Okay, let me just unlock that. These cell scripts. Now, on this cell script, there is right above it a transform, and every transform has a position, rotation, and scale. So essentially what I am doing is within this code is I getting the item, which is a cell or a cell piece. I'm getting the transform and then getting the position from that. And this positions is the cell positions right here. So I'm checking if any of these cells right here has the same position as a position within our positions list, which means let's say we have tile 0. It has a position of 0, 0, 0. The positions at position 1 will be 0, 0, 0. Therefore, this part will be true. What I am going to do, however, is I'm going to change this from a list to an array. So an integer array, I'm going to call it TMP again, equals a new array with 9 spaces. This makes things easier because TMP at position I now has a open space. So I won't try and add something to a position that does not exist. And what I did right now is in that open position, because the I is its index, we need to add the value of that cell. And after this, you will see how it looks, how the board looks, how the computer will understand what is happening in a later stage. Everything we are doing now is going to be used in a later stage, far later in the video. The reason we are doing it now is because we can use the same methods to see if the board is currently in a win state or a goal state. So item.self_value is added, and after this we want to break because we do not need or want to continue. And because after this we have an else, and all we're going to do is we're going to set temp.I equals to -1. Now that is going to allow us to represent the missing block as a -1. Now after all of this we have temp, so after the for and for each, all I'm going to do is up here we have at board, we're going to go board equals to tmp dot to list. No, dot to list, not string. Okay, so what we can do now is on start is we can say calculate board. If we go into Unity, we will be able to see that in action right here on Game Manager at board. As you can see, the current size is 0. And once we start, we will see something went horribly wrong. Yay! Okay, I know exactly where I went wrong. In the positions, I said 0, 0, 0, 1, 1, 1 for the Y position, but that insinuates that we start at the bottom left and go up. But since 0, 0, 0 is our top left, our Y value should decrease every time we go down. With that corrected, we can play again. And we have at element 0, 0, 1, 2, 3, 4, 5. 5 and 4 are... I only realize now that I switched 4 and 5 around. Now you can see that the code works in its intended course, in its intended way, and at element 8 we have -1. So, and since we want to make sure the puzzle is solvable, we're just gonna switch these two around.